Flying high in the sky, men saw a sea of clouds, cutting through mountains, running through underground, reclaiming lands towards open sea, creating new energies for a prosperous, plentiful life, convenience for everyone, richness for everybody. Hong Kong, one of the most beautiful ports in the world, has developed and prospered as an important center of international trade, creating new challenges in both the public and private sectors. For today, Hong Kong faces shortages in housing, transportation, and energy. However, Hong Kong is working to solve such problems. Everywhere, you can hear energetic sounds of construction hammers. Everywhere, you can see international firms building a new Hong Kong. Aoki Construction Company Limited first joined in these activities in 1976 by taking part in the construction of the Hong Kong Mass Transit Railway. Ever since then, Aoki has actively participated in a variety of large construction projects there by bringing in from Japan and the United Kingdom many highly skilled technical personnel and up-to-date heavy construction equipment. This film presents 5 large-scale construction projects that Aoki Construction Company has undertaken in Hong Kong as of March 1981. In 1970, the Hong Kong government decided to build the mass transit railway system, connecting the island of Hong Kong with the Kowloon Peninsula. The first phase was the construction of the route between the Central District and Kwun Tong. The route comprised 15.6 kilometers of double-track railway system, predominantly underground. Starting from Chater Station on Hong Kong Island, the route ran northwards, crossing the harbor by a twin submerged tube tunnel about 2 kilometers long. From there, it continued towards Prince Edward Station on the Kowloon side and then turned eastwards in a large curve to reach its terminus at Kwun Tong Station. Of this route, Aoki Construction Company undertook Contract 109, comprising 3 sections of tunnels located at each end of the immersed tube section, totaling 2,526 meters. Thus, the MTR project, the largest of its kind in the Orient, started under the keen observation of other contractors and governments around the world. Contract 109 was one of the most difficult sections, requiring very high technology to overcome the construction conditions. Hong Kong's peculiar ground conditions, with layers of completely decomposed granite and soft soil layers with large boulders, made it necessary to do much of the tunneling with explosives, under compressed air with pressures as high as 2 kilograms per square centimeter. In addition, consideration had to be given to the many high-rise buildings nearby and their complicated underground facilities. The underpinning of the foundation piles, along with utility tunnels and equipment, required the tunneling work to be carried out with particular care. The tunnel alignment was also complicated. The 4 tunnels leaving Chater Station were designed to change from upper to lower levels and vice versa before entering Admiralty Station. For the tunneling method, 6 large diameter shield machines having outside diameters of 5.36 meters were used for the first time in Hong Kong. The tunnel was lined with either ductile iron segments having an inside diameter of 5 meters or precast segments of 3.9 meters ID, depending upon depth and ground conditions. The allowable deviation was only 1.35 meters. It also involved the particularly difficult job of connecting the tunnels to the previously submerged dual tunnel tube at the bottom of the harbor. As far as is known, this type of operation had only been attempted 3 times before anywhere in the world, with only one known success. The construction work progressed steadily, and the day of the trial run of the MTR train came at last. MTR staff, contractors, and other people involved in this project were all aboard the train making the maiden trip and they observed with amazement the achievements of the world's foremost civil engineering technology. Thus, the initial system of the Hong Kong Mass Transit Railway was opened in February 1980, 2 months ahead of schedule. Today, it is busily serving the people of Hong Kong as a key means of transportation, combining Hong Kong Island and Kowloon Peninsula by undersea and underground tunnels. Based on the success of Contract 109, Aoki Construction Company further participated in the international tender for the construction of Phase 2 of the MTR system, the Tsuen Wan Extension Project, and was awarded Contract 305. The Tsuen Wan Extension is a route branching off from Prince Edward Station of the Phase 1 route and running northwest to the town of Tsuen Wan. The work involved in Contract 305 includes construction of 480-meter-long cotton-covered tunnels of up and down lines, ventilation buildings, the Tai Wo Hao station structure, and 2 tunnels totaling 1,500 meters on both sides of the underground station structure. This is the East Tunnel, where it joins with the cut-and-cover tunnel section, combining up and down lines. Here again, the project conditions were just as difficult as those of Contract 109. Many high-rise buildings had to be worked around, and in some places, the tunneling had to be carried out only 9 meters beneath the existing road surface. In particular, the geological formation underneath Castle Peak Road was very soft and weak. At first, the PC segment lining method was to be used. But Aoki's technical staff, always aiming at faster and safer construction, made a careful restudy of the geological conditions and proposed the short bench cut method accompanied by a thorough grouting system. Also, under certain ground conditions, 8-shaped structural steel supports and rock bolts installation were used along with shotcreting. The structure of Tai Wo Hao Station consists of 2 underground levels. The upper level comprises the concourse, ticket office, station master's office, and machine room. The lower level includes an island-type platform, 2 tracks, and other facilities. The West Side Tunnel starts from the west end of the station structure and extends 311 meters upline and 303 meters downline towards the section of Contract 308. The excavation started from a 15-meter deep shaft provided near the beginning of the Contract 308 section. A hand-dug caisson method was adopted to provide shaft wall supports. In this section, construction 185 meters upline and 179 meters downline were to be carried out in the layers of sand and soft sandy soil. In order to prevent the lowering of the underground water table or excessive ground settlement, the boring tunnel with upper half section ring cut and short bench cut method was adopted with the use of pressure chambers. Here, the boring tunnel, using pressures up to 1.5 kilograms per square centimeter, is now underway. On July 23, 1980, the East Tunnel was successfully broken through. This portion was the downline section of the East Tunnel, one out of the 4 tunnels that comprise the up and down lines of the east and west side. Having constructed the portal in September 1979, it took a little over 10 months to break through, 3 months ahead of the schedule. Mr. Russell Black, the representative of the Mass Transit Railway Corporation, who is in charge of this project, detonated the final blast to break through the remaining section of rock. The remaining 3 tunnels are being completed one by one. Soon, the structure of Taiwo House Station will be completed. Approximately 8 kilometers northeast of Kowloon is the district of Sha Tin, along the route of the Kowloon Canton Railway, which connects Kowloon with China's Guangdong province. As one of the measures to solve its ever-increasing population problems, the Hong Kong government decided to develop a new town in this district, which will eventually have a population of 700,000. To avoid discharging untreated domestic and industrial sewage into local water, the Sha Tin sewage treatment plant was designed. An Aoki construction company succeeded in obtaining the contract to construct Phase 1, which would handle some 102,000 cubic meters per day. The project is a vast facility designed to treat the sewage generated by this enormous concentration of people. However, when work first started at the project site, which covers an area of almost 200,000 square meters, or about 50 acres of reclaimed land, the Aoki staff found to their dismay that the ground conditions were extremely adverse. The soft and unstable ground which they discovered could not have been foreseen by anyone. In order to improve these conditions, Aoki immediately applied their innovative paper drain method. This patented method, which was invented by Aoki Construction Company, had already been successfully used in Japan many times in the past for improvement of soft ground. This was, however, the first time it had ever been used in Hong Kong. Work continued on the project. One of the highlights was the underwater installation of large diameter concrete pipes for the outfall. Each of the concrete pipes, having an inside diameter of 98.4 inches, or about 2.5 meters, weighs about 10 tons. Upon completion, a total of 2,100 linear meters of pipe are to be installed, with an allowable deviation of only 5 centimeters. Although the technology for such works has become well developed in recent years, even in open seas, here in Hong Kong, such large diameter pipes have never been installed underwater before. For this particular installation work, the so-called hydro-pull method has been adopted to join a pipe segment to the preceding segment by utilizing pressure differences in the water between the two. In an operation such as this, close cooperation between all people at the project site is essential. Together with UK engineers and Chinese staff, Aoki employees are working hard as part of the overall team effort. And in the process, young Aoki men are always developing their sense of international cooperation and teamwork. Meanwhile, work has commenced on the powerhouse, which will produce electrical energy from the heat generated by the sewage treatment process. Thus, the treatment plant will be partially energy self-sufficient. The construction of the Shatin sewage treatment plant, the foundation of a clean environment for 700,000 people, is now steadily progressing towards its completion. Plans for Shatin New Town naturally required increased transportation facilities for the people living there. As well as the mass transit railway system, the Kowloon Canton Railway serves as a major transportation artery in Hong Kong. It was originally a single-track system, but recently, plans were introduced to improve it by converting it to a dual-track system. The Beacon Hill Tunnel, running underneath Lion Rock, had also been built to accommodate only a single track. Thus, a new double-track tunnel was to be constructed only a few meters away from the existing tunnel. It was to be 2,318 meters long. The contract was awarded to Aoki Construction Company in 1978. This project also involved various problems. Because the new tunnel passed beneath a residential area, the use of blasting was limited to twice a day. Yet, the construction period allowed was only a little over 900 days. To stay within such a difficult schedule, Aoki decided to employ a 7-boom hydraulic drill jumbo. Aoki's project site chief engineer explains the reason for its use. This drill jumbo had never been used before in Japan except for a couple of experimental uses, so we were hesitant to use it. However, because it can bore holes up to 3 meters for one blasting cycle, we decided to bring it in. The hydraulic drill jumbo has a drilling speed almost twice as fast as conventional air drill machines, and can bore holes of 45 to 217 millimeters in diameter. Because its lateral boring is very accurate, it is highly suitable for the burn-cut method. Furthermore, since it doesn't operate on air, drilling noise is almost 20% below the maximum allowable level. On top of these advantages, it is able to adjust its impaction and rotating strength automatically according to the variation of rock characters on which it is working. Thus, it widely improved energy efficiency and saved considerably on power costs. On April 23, 1980, a little over 2 years and 4 months after the work started, the day of breakthrough came at last. Exactly at noon, Mr. H.D. Stead, Director of Engineering Development of the Hong Kong PWD office, who was in charge of this project, detonated the first blast. After the traditional purification ceremony, men from both the north and south sides of the new tunnel met at the new opening, firmly shaking hands with each other. Final finish-up operations were then carried out. And on April 20th, 1981, after 54 hours of round-the-clock work to switch over the track from the old tunnel to the new one, the first train to use the new tunnel broke through the inaugural ribbon. In June 1978, Aoki Construction Company, which had steadily gained valuable experience in Hong Kong, took on a project of unprecedented size, namely the construction of the Castle Peak Power Station site. The contract was awarded to Aoki only after strong competition from a joint venture of local, French, and Italian contractors. The contract was an enormous construction project involving both land and sea operations. Huge volumes of rock and earth were moved by extra heavy-duty equipment, and the reclamation and shore protection works were carried out by a fleet of Aoki's internationally patented pusher barges. These special operations are areas in which Aoki particularly excels, backed by its superior technology and extensive experience. The first phase of the project was the formation of the power plant site, starting with excavations at a hillside in the Tap Shek Kok area, located at the southwestern tip of Kowloon Peninsula. Altogether, some 10 million cubic meters of rock and earth were excavated and deposited in the sea, reclaiming about 50 hectares of sea area. Added to the 40 hectares of land formed on the hillside after excavation, the entire power plant site covered 90 hectares. In order to complete this huge project in a limited time, large numbers of D9 bulldozers and 46-ton dump trucks were brought in. The heavy equipment moved up to 20,000 cubic meters of rock and earth a day. Although it may look like a confused battlefield, their moves were predetermined and controlled by carefully computerized calculations, and were based on rationalized formation of each piece of equipment. Meanwhile, at sea, 3 4,000 deadweight-ton pusher barges were busily operating, together with 4 crane barges. The pusher barge, which is sometimes called an ocean-going dump truck, can transport enough rock and earth in one trip to fill a 46-ton dump truck 87 times. The rock and earth were loaded by a conveyor belt system onto the barge, carried to the reclamation dumping spot, and then, by simply opening the bottom of the barge, the load was instantly dumped. Thus, the work continued day after day at an extraordinary pace. The power plant site began to take shape so rapidly that its appearance changed daily. At last, in November 1980, a ceremony was held to demonstrate the final fill and grading, and thus the formation of the 90-hectare site for the Castle Peak Power Station was completed. While this operation was being carried out, Aoki was also working on the circulating water system for the power plant site. Here, the extraordinary new sink and set method was applied. For example, This method was used in the fabrication and installation of the reinforced concrete box-type cooling brine intake structure, as well as the brine intake culvert. The result was significantly easier operations at lower cost. First, a dry dock was built at a part of the reclaimed land where the cooling brine intake structure was built in its vertical position. At the same time, the brine intake culvert, about 90 meters long and 9.5 meters wide, was built utilizing the roof of the existing culvert as another dry dock. It was planned that when they were completed, water would be introduced into the dry dock and the bulkhead floated into position some 100 meters away. The idea here was to keep the transit distance as short as possible, while also minimizing the dry dock area. The installation of these structures took place during the midnight high tides of February 4th and 7th, 1981. First, the intake culvert was pulled out by a floating crane. This crane is the largest of its kind in Hong Kong and was successfully set. Then, the pulling out of the brine intake structure was carefully begun. As it was being moved, the structure was half turned and brought to the set position, then perfectly installed in a horizontal position. The operation continued through one full day and night. Technical skill, ability, and innovation. Aoki civil engineering skills and techniques are changing Hong Kong, building up the foundation for its continued prosperity. Soon, here in Castle Peak, you will see a lively coastal industrial region with a 4.3 million kilowatt capacity power plant, a cement plant, and other major industries. Furthermore, the power plant will supply energy not only to Hong Kong, but also to mainland China, providing a better life for an even greater number of people. We have covered only 5 of the Hong Kong projects being developed by Aoki Construction Company. Others include the first 2 contracts to be awarded for the MTR's new Island Line extension, a multi-story warehouse, and 2 further sections of the Kowloon Canton Railway. Again this year, the company welcomed a new group of high-spirited freshmen who will be tomorrow's leaders in Aoki's expansion into overseas markets. Now that you are members of Aoki Construction Company, I want you to do your best, and that means every day, to the best of your ability. By doing so, you'll be benefiting not only the company, but yourselves as well. You are the future of the company. You are the ones who will decide if we succeed or fail. Flying high in the sky, man saw a sea of clouds, cutting through mountains, running through underground, reclaiming lands towards open sea, creating new energies for a prosperous, plentiful life. The 4 letters, Aoki, wave proudly on the company's banner, symbolizing its future activities in markets around the world.